In this video, we are going to see how to convert a circuit with dependent sources into equivalent Thevenin and Norton circuits. Now let's look at the standard equivalent Thevenin and Norton circuits. So for a standard Thevenin circuit, we have to have V Thevenin. Here we are going to have V Thevenin, R Thevenin, and a load resistance. Okay. So this will be our V Thevenin, and this will be our R Thevenin, and here we will have our load resistance. Okay, and the equivalent Norton circuit is going to look like this. We will have a current source that's going to be I Norton, and also we will have R Norton. Okay, let's draw that one here. This will be I Norton, R Norton, and we will have a load resistance. So this is I Norton, and here we will have R Norton, and here we will have load resistance. Okay, now when we have dependent sources alone, what's going to happen is this V Thevenin and this I Norton will be equal to 0. So here this will be equal to 0, and this also will be equal to 0. So this will not exist, right? These two will not exist. So we just have to find R Thevenin, and if we find R Thevenin, that's going to be equal to R Norton, and that's it. If we find that one, that's going to give us the equivalent circuit. Now in order to find the R Thevenin, what we can do is first we remove this part. Okay, we remove this part, and here we will connect a source. So let's go ahead and redraw the circuit. Okay, here we will have a circuit like this, and this one is going to remain. And what we are going to do is we keep the other things as it is, and in this one we are going to add a source, right? We just remove this resistor, and instead of that we are going to add a source. Here you can add current source or voltage source, it depends on the situation. Here I'm going to add current source, and you can give a easy value. For example, we can give 1 ampere, and this one remains. This is going to be 4 ohm, and here we will have 1 ohm, and we can combine these two together. Since these two resistors are in series, we can combine these two together, and that's going to give us 6 ohm. Okay, so here we will have 6 ohm resistance, and this is going to be our dependent voltage source, plus minus 2ix, and ix is in this direction. Now to make this one easier, what we can do is we can do the source transformation. In that way we can reduce the meshes, right? We can bring it into one thing. But before we do that, also we have to know that voltage across this 1 ampere source is going to be equivalent to voltage across this 4 ohm resistor. Okay, right, this is the only thing we have to know. And we are going to do the source transformation. If you do the source transformation, this is going to be P is equal to IR. So we will have a voltage source that's going to be 1 times 4, that's going to be 4 voltage, right? So let's redraw the circuit. Here we are going to have the new circuit. Let's draw with a different color. Okay, this is our new circuit. In this one we are going to have this resistor in series. So this 4 ohm is going to be in series. Here we will have a voltage source, and this 6 ohm resistor remains here, and here we will have this 2ix. Okay, and this one is going to remain here, plus minus 2ix, and here we have this 6 ohm, and here we have this 4 ohm resistance, and here we will have this voltage source that's going to be plus minus, and that's going to be 4 voltage, right? 4 voltage, and here we will have this voltage across this one. Now here I'm going to apply the Kirchhoff's voltage law. So if I apply KVL around this one, around this loop, so let's assume Ix. Okay, here this is going through this negative to positive, so this is going to be negative 2Ix. Then it's going through the 6 ohm resistor, so 6Ix plus 6Ix. After that it's going through this 4 ohm resistor, that's going to be 4Ix, and plus 4V. 4 we can just write 4 is equal to 0. And from this one we can calculate our Ix. Let's combine these three together. 10 minus 2, that's going to be 8Ix. 8Ix is equal to negative 4. Therefore Ix is going to be equivalent to negative 4 divided by 8, and that's going to give us negative 0.5 ampere. So that's going to be the Ix current. Now what we are going to do is we are going to think this imaginary border. We are going to create an imaginary border right here, and we are going to create another Kirchhoff's voltage law in this one, okay, Ix, and in this one alone. And if you apply this one, this is going to be minus to plus, so this is going to be negative V, and for negative V and going through this 4 ohm resistor, there's going to be 4 Ix, and plus to minus, so this is going to be plus 4 voltage is equal to 0. We are interested in finding this voltage, so this one should be 4, right? This one should be 4 right here. 4 is equal to 0. We know that I of x is equal to negative 0.5. We can plug that one right here. So this is going to be negative V, negative 2, and this is going to be plus 4. So we are going to have plus 2 right here. So V is equal to 2 voltage. V is equal to 2 voltage. So from this one we can calculate R Thevenin. R Thevenin is going to be equivalent to this V over, okay, V is equal to IR, R is equal to V over I. We know the V divided by I is 0. Okay, V is 2 voltage, and that one divided by R Thevenin. Okay, let's see. R Thevenin is equal to V over I. Okay, we have 1 ampere right here, right? So voltage is 2 divided by 1 ampere, that's going to give us R Thevenin, and that's going to be 2 ohm. So here our R Thevenin is 2 ohm. So the equivalent resistance is going to look like this. We are just going to have this 2 ohm resistance and the load resistance, that is 1 ohm, right? So this is 2 ohm is the R Thevenin, and this is 1 ohm, 2 ohm and 1 ohm, and that's it. This is our equivalent resistance for equivalent circuit for this given circuit. This is going to be the Thevenin circuit, and also the Norton circuit also going to be the same thing, because R Norton and R Thevenin are equal, and if we put R Norton and R load, it's going to be the same thing, right? So Thevenin and Norton circuit are going to look like this: 1 ohm, 2 ohm, that's it. I hope this helps. Thanks for watching.